All right, final test review, pre-calculus B. I've already got part of the information drawn, but it says determine the equation of a parabola. So we got to know that there are y equals ax squared kinds that go like this or like this. But there are also x equals ay squared kinds that open up to the left or to the right. So right away, with the given information, y equals -3 is the directrix. It's right here. Focus, 4, -5. We know the vertex needs to be right in between them. So that tells us a lot of information. So number one, it's going to be a y equals ax squared kind because it's down, just like this. We also know that a has to be negative. The only way you can have a downward parabola is if this a is negative. Number three, c is 1. You can look at the distance from here to here or here to here. It's going to be 1. Now we can put that together right now and use the formula a equals 1 over 4c and go 1 over 4 times 1, which is just 4, but it's negative, and this formula will not give it to you. You need to figure it out. So you insert it, and then you think, okay, if the vertex was here at 0, 0, your answer would be y equals -1/4 x squared. However, notice the vertex, I'm going to try to squeeze this in here, would be 4, -4. Here's my x adjustment, here's my y adjustment. So how do I make my x adjustment? Right in here. So I'm going to put it right up here. It's going to be y equals -1/4 x, and to move it right would have to be -4. Don't forget the squared. And then if I want that vertex to go down 4, which it does, then I put the -4 on the end. And that's it for number one. That's a lot of work for the first problem. And I just peeked at the answer, and the answer doesn't quite match this, but remember, for some reason, pre-calculus B all of a sudden wants you to isolate the squared portion of your answer. So we're going to add 4 to both sides, and we'd get y plus 4 equals -1/4 x minus 4 squared. Now we're going to have to multiply it all by -4 to get rid of that. So this would hit this and this. So we get -4y minus 16 equals x minus 4 squared. Okay, number 2. It says find the focus of the parabola, Well, first thing we have to do is realize this either matches with this generic equation of a parabola or this matches with this generic equation of a parabola. So what I'm going to do is I'm going to turn this thing around. I'm going to go -8 y minus 3 equals x plus 1 squared. And we're going to try to guide this so it looks like this one, because as you can see, the y is not squared, the x is squared. So I'm going to multiply this by -1/8. That would give me y minus 3, because these two things would cancel, equals -1/8 x plus 1 squared. Now back in Algebra 2, you would actually find the vertex from here. You'd say left 1, up 3. But pre-calculus gets you guys trained to get rid of it over there. So you look at it as y equals -1/8 x plus 3 squared plus 3. Now there's not a whole lot of space here, so I'm going to have to write quite small. But this tells us to move our vertex 3 to the left. 1, 2, 3. This says go up 3. 1, 2, 3. There it is. There's the vertex. Now because this is negative and it's a y equals x squared kind, it's going to go like this. Now to find the focus, and that's what it's asking us to do, we got to know the letter C. Where are we going to get that from? Right here, because that's my A. So remember, A equals 1 over 4C. So 1/8 equals 1 over 4C. Now, if you're observant, you would notice I left the negative off, and that's on purpose because we're going to find C, and C is a distance. We don't want that negative involved in this at all. So 4 times 2 is 8, so we know that C is 2. We know that our tulip goes around the focus, so we know that we need to go 2 units down from here. Remember what we said? We said this right here is -3 and then up 3. We need to go 2 down from that. So the focus would be right here, which would be -3, 1. A lot of work. Those darn parabolas require a lot of work. They just do. Okay, so you would think after doing this math a million years, I'm not quite that old, but I'm getting up there, that I wouldn't make these silly mistakes. But as you can see, somehow I went x plus 1 to x plus 3. This is supposed to be x plus 1. So that drawing would be wrong. And so we would have to go over here, and we'd say, all right, left 1 up 3. So left 1 up 3. And there it is. And so that would be -1, 3. And my drawing would be like this. So everything else is the same. C is 2. And I'd have to go down 2 from there, taking me to -1, +1. There's my focus. So it's not this. It's -1, +1. All right. Number 3. Let me get the drawing for you, and then I'll be back. All right. So we got a kickstart on number 3. It says one of the foci is -2, 4. It's right there. The other one's 6, 4, which is right there. I drew a real generic drawing of the ellipse. It'd have to be longer this way because remember, the foci are always on the major axis. Major axis is the long axis. Now notice, it says the major axis is 12 units long. That means from here to here is 12. That means half of it would be the letter A. So let's go ahead and find the center. If this is -2, 4, and this is 6, 4, we can see that there's 8 units between these two, so I'd go 4 in from here or 4 to the right from here. Regardless, I'd end up with the center being 2, 4, and that's huge. 2, 4. Because that's the center, I now know that it's going to look like this. X minus 2 squared plus y minus 4 squared equals 1. So really, I'm on a mission now. I got to figure out what a squared is, and I got to figure out what b squared is. Now, did I randomly put a squared here? No. A is bigger than b in an ellipse because that represents the major axis. Now, it says the major axis is 12 units long. That means a is 6, which means I can square that, and this would be 36. I know it's messy, apologize. And I can also look at this, and we already said it, C is the distance from the center to the focus, and that would be 4 units long. So I'm going to use this formula, a squared, I'll do it over here because there's more space, a squared minus b squared equals c squared, and c is 4, so I'm going to square that to 16. Subtract 36, subtract 36. So I get -b squared equals -20. That means positive b squared equals positive 20. And that's what I'm going to put right here, 20. So there's my equation. If you wanted it a little neater, it'd be x minus 2 squared over 36 plus y minus 4 squared all over 20 equals 1. Okay, number 4 is going to piggyback number 3 a little bit. I've already found the center of the ellipse by saying 3 to the right, and then this is not going to move it up or down, so there's my center right there. That center is 3, 0, which will be significant because they're asking us to find the foci. Notice 16 is bigger than 4. That means my x-axis is going to be my major axis. However, we could go, if we actually drew this a little bit, we'd say, and we don't need to because it's just asking us to find the foci. But we're going to take the square root of that, which is 4, so 1, 2, 3, 4. And then 1, 2, 3, 4. And see, now I know that my ellipse is going to look something like this. Something like this. Yes, if I took the square root of that, it'd be 2, and I'd move up 2, down 2. But it's asking me to find the foci. which means I need to find C, because C is the distance from the center to the foci. Foci is going to be here, it's going to be here. So I'm going to use the formula right here. A squared minus B squared equals C squared. So C squared equals 12. So if I take the square root, and a strange thing in pre-calc, they don't start breaking these things down. Let me check and make sure. Yeah, so they're not going to break it down, but bada boom, bada bing, do the right thing. That little rhyme helps you remember that from here I'm going to move the right square root of 12 and to the left square root of 12. So it's going to hinge on this. So my answer would be 3 plus or minus the square root of 12, comma 0. That means move to the right square root of 12 and move to the left. Do not move up or down. And that's it for number 4. And I looked at number 5. It says determine the vertices. The vertices are the endpoints of the major axis, which we actually discovered in this earlier problem. I didn't mean to do it, but so if we take the square root of 16, that's 4. It means I got to move 4 to the right, so that would be 7, 0. And I have to move 4 to the left, which would be negative 1, 0. So there's the vertices. That was easy. Okay, number 6. Accidentally drew this little silly thing in, but I know that the vertices 0, 3, 0, negative 3 are here and here. Foci 0 plus or minus 5 would be here and here. And therefore, my parabolas have to go around the foci, but it's called a hyperbola. So concentrate on the orange lines, because if we think of this as Pac-Man, and they gobble up the what axis? They would gobble up the y-axis. So that means it's going to start out with, and also the center of this hyperbola is 0, 0, which makes our life very easy. So it's going to be y squared over a squared minus x squared over b squared equals 1. So we got some work to do. But it does tell us that the vertices are 0, 3, 0, negative 3. So that is called my transversal axis, so that's just telling me that A is 3. So if I square that, I know this is 9. And the foci are 0 plus or minus 5, which is from here to here, also here to here, but we're just going to take this. So I know A squared plus B squared equals C squared. I know A squared is 9. B squared we're going to try to find. C squared is 25. If I subtract 9, I get b squared is 16, and I put it right here. So that would be y squared over 9 minus x squared over 16 equals 1. So it's not required, but I'm going to go ahead and graph this. Maybe somebody will benefit from that. I'm not going to graph it perfect, but if I take the square root of 36, I know it's 6, and that's the distance I need to travel along the x-axis. And so I put a point there and I put a point there. I take the square root of that, which is 8. And that's how long I got to travel up the y-axis. So I'm going to make that 8. I'm going to make this negative 8. This is where I make my hyperbola box, drawing my diagonals. And because it starts with x squared, I know it's going to eat, if they were Pac-Man, they would eat the x-axis. So it's going to look like that. And you need to know generally which way these hyperbolas are facing, because the foci are going to be somewhere here and somewhere here. So that helps us with our final answer. But now we're going to use the formula a squared plus b squared equals c squared. We know a squared is 36 because it's first. B squared is 64. Gave us a nice, neat little answer on this one. So bada boom, bada bing, do the right thing. So it's plus or minus 10. So from the center, I need to go 10 to the right. That'd be 10, 0. 10 to the left, negative 10, 0. So that'd be plus or minus 10, 0. So I've got 40 seconds to do this one. Squeeze it in. Square root of 36. Well, actually, this is the same as this. So we're going to cheat. We're going to take this. So the vertices would be here and here. Well, that was easy. So that'd be 6, 0. And negative 6, 0. The vertices are basically the vertices of your individual parabolas. So it'd be there, and it'd be there. So there's your answer. I'll see you at part 2.